In today's video, here is a nice problem. It's coming from Australian Mathematical Olympiad edition 1993. Here is the following setup. We have x and y as a positive integers. We have this following equation. It's coming on the form of the exponential. We have 2 to the x minus 3 to the y equals 7. Okay? There is too many different ways we can solve this one. So you guys, you can give the try to from pre-regime to solution. Go out pause this video when you come back to step 4 solution. Okay? Now let's go through this one. So here is the following equation. 2 to the x minus 3 to the y equals number 7. Okay? Actually, before I start solving this one, I'm going to prove x cannot be odd. X must be even. Okay? By reducing this equation to lemma 3. So first of all, I'm going to split this number 2 over 2 terms. I get here 3 minus 1 to the x minus 3 to the y. I get here 6 plus number 1. Okay? So by reducing this one to lemma 3, so I get here this one 0. This one is giving me minus 1 to the x. This one actually is 0. This one is congruent. This one is 0. I will be left with number 1 mod 3. Okay? So here is the thing. So in order to have 3 divides this term, actually if we want this statement to verify this condition, x must be even. Okay? If x is even, which means this one turns into number 1, I will have 1 is a congruent to 1 mod 3. By taking this number 1 to the left, I get 0 is a congruent to 0 mod 3, which means 3 divides 0. Okay? So if it is odd, if x is odd, this minus 1 turns into the minus 1. Minus 1 is a congruent to 1 mod 3, which is impossible, which means x must be even. Okay? So if x is even, let's set x equals to n. Okay? So we know that x is even now. So I'm simply going to take this value of x and plug it into this equation. I will have 4. As I'm replacing x with 2n, I get 4 to the n minus 3 to the y equals 7. Actually, number 7, I'm going to split this 7 into 2 terms. I get 7 equals 4 plus number 3. Okay? Why I'm doing this one? Because I have 4 to the n here. I'm going to bring this number 4 to make it as a common multiplier. Also, I have a number 3 to the y. I'm going to put this one and this one together. So this one is giving us 4 to the n minus number 4 equals 3 to the y plus number 3. It's very clear here. Basically, this one is bigger than this one, so I'm going to take number 4 as a common multiplier here. I get number 4 factor 4 to the n minus 1 minus number 1. On the right hand side of this equation, I get here number 3 is multiplied by 3 to the y minus number 1 plus number 1. Okay? So actually, we know this one is term is odd, this one is odd. So I'm going to transfer this one into the product by factoring this one, by factoring out this term. So also, if you take a look again, 4 to the n minus number 1, I'm going to put this number 4 as 2 square. Okay? So I will have 2 square, which means I will have the difference of 2 squares here. So this one equivalent, I get 4 factor 2 to the n minus 1 minus number 1 factor 2 to the n minus 1 plus number 1 equals 3 is multiplied by 3 to the y minus number 1. As I'm factoring out this one, I get here 3 plus number 1 factor 3 to the y minus 2 plus 3 to the y minus 3 and all the way down to the number 1 like this. Okay? So here is a nice thing here. This 3 plus number 1 becomes 4. So I'm going to cancel out number 4 from the left and the right. I will be left with this product equals this product. So thus I have 2 to the n minus 1 minus number 1 factor 2 to the n minus 1 plus number 1 equals 3 is multiplied by 3 to the y minus 2 plus 3 to the y minus 3 and all taking this one all the way down to the number 1. Okay, I've ended with this nice expression. Here is a thing here. So the problem, so by making the comparison between the left and the right hand side of this equation, so we don't know this term equals to this term or equal to this term, because here is a big number here, we don't know about it, we cannot know how far this one is going. Okay, so what I'm going to do now, I'm going to prove this term cannot be 3. Okay, we know this term is smaller than this term, and also GCD of this term, GCD of this one equals 1, because both terms are consecutive odds. Okay, what does mean GCD equals 1? If 3 divides this one, which means 3 cannot divide this one. Okay, so I'm going to force this one cannot be equals to 3. So by the way of contradiction, I'm going to suppose this one equals 3, then we solve the equation. At the end of the term we will find the contradiction. Okay, let's, by the way of contradiction, suppose 3 equals 2 to the n minus 1 minus number 1. Okay, if we know the parity of n as an exponent, it will be very simple to determine which term 3 is going to take. Okay, but since we don't know the parity of this one, so I'm going to go through the absurd proof. So it's clearly, I'm going to move over this minus 1 to the right, is giving me 4, which equals 2 square, which equals 2 to the n minus number 1. Okay, it's clearly number 2 equals n minus 1. In the other word, n equals 3. If n equals 3, which means x equals 6. X equals 6. If x equals 6, I'm going to check what's the value of y here. Okay, so this one, I get 2 to the x, which is 2 to the 6, by moving over number 7 to the left, minus 7, by taking also 3 to the y to the right. 2 to the 6 it's clearly is 32, minus 7 is given as 25. Okay, this is 25, which equals 5 square. But the problem, the left hand side of this equation is a power of 3, but the right hand side of this equation is a power of 5, which it's clearly it's a contradiction. Okay, which means the assumption that I have chosen here doesn't work, which means 3 is not going to take this one, 3 is going to take this one now. Okay, so thus 3 is taking this value 2 to the n minus number 1 plus number 1. Okay, if 3 is taking this value, which means this term is going to take this term. Okay, but the problem, this term is smaller than this term, which means this term must be equals to 1, since this one is an odd. Okay, because this one is an odd, this one is an odd. So this one is telling us 3 equals to this term, which means this term must be taking number 1. If this one is taking number 1, which means the whole thing is turned into 1. If the whole thing is turned to 1, which means the exponent must be 0. So I have 3 to the 0, which is 1. Okay, which means this exponent equals 0. In the other words, y minus 2 equals 0. That means y equals 2. Okay, and also I'm going to solve this equation by determining the value of n here. So I'm simply going to move over number 1 to the right, to the left. I get here 3 minus 1, which is 2, equals 2 to the n minus number 1. Okay, the exponent is clearly equals 1 here, which means n minus 1 equals 1. In the other word, n equals 2. Okay, if n equals 2, the equation is already solved, because x equals 4 here. If x equals 4 and y equals 2, they are the solution for this equation. Okay, so which means x equals 4 and y equals 2 is the only solution for this equation. If you plug these values into x and y, we will find, given as number 7, okay?